Great. Thanks, Alan. Thank you to CitA, and hopefully you get some positive feedback on this presentation today. So I'm going to give you a whirlwind tour of the last 20 odd years of my career, um, and dealing with this topic of the impact AI is going to have in construction. Personally, I think we've got a 10-year roadmap in front of us. For some people, it's going to happen very quickly. For most people, it's going to happen over a long period of time. So I'm going to explain why I think it's going to take longer than you might think, based on my experience. So what impact is AI going to have in construction? It depends where you sit. As Alan mentioned, the BIM is used less than 25% of projects today. So we all know the major projects are using it, all the big airports, all the big infrastructure projects. But what about the normal commercial projects? They're not all using it. So why? In order for AI to be fully unlocked, you need to have a foundation in BIM. So AI is going to be useful, but not as useful without BIM. So we need to understand how to unlock the value of both. And it is going to propel some firms forward faster than others. Other firms are going to struggle. So I'm going to share with you why some of those struggles are going to become real very quickly. So very briefly, I graduated in 96. I worked at ARPS. The first model that I came across was in 1999, working on the Irish Expo in Germany. And that set me on my path to where I am today. I moved to Hong Kong in 2000, and I created my first company in Hong Kong in 2003. So in 2003, when I set out to do BIM, we were looking at things like modeling, design coordination. And I actually just going to share with you some slides that I presented 20 years ago. So these will be relevant to some people today, but this is what it looked like 20 years ago. So this is a model that we created. And we basically use the same principle. So you make a model of the structure, you model as much detail as you can, you model all the mechanical systems, ductwork, pipework, cable trays. Anybody who does BIM now, this is common practice. And then you put all that together into a federated model. And in 2003 and 2005, we were using things like CAD. This is pre-Revit. And we were basically visually checking the models to see if we could find coordination issues. You jump forward a couple of years, 2007, when BIM became kind of the first iteration of BIM, if you will. The idea here being that everybody works in a central model of some description. The consultants all work in a 3D modeling environment. They do their coordination, they do their clash analysis, and then they do the drawing production. So you end up with your contract drawings, your schedules, and your budgets. So the interesting thing here is some people say BIM is new, but it's not really new. It's at least 15 to 20 years old. And then, as far as I can figure out, in 2007 was the first time I came across the term of a BIM manager. And then you have all the different roles inside the different design teams. So these are a couple of slides from the company that I created way back when. Now, what's interesting is when you compare what was going on 20 years ago and you look at what's happening today, the standout again is Autodesk. So Autodesk were behind Revit. They drove the changes in the industry. They drove the promotion of BIM quite heavily at the beginning. And now when you look at what they're doing, they're about to change how we do work in the industry again. And the reason I say that is I was at a presentation only last week in Singapore, and they talk about this Autodesk Forma. And Forma is going to change the way we deal with data in construction, at least in Autodesk's mind. And what I want to share with you is just a couple of snippets from an advertisement that's currently on LinkedIn. So if you're looking for a job in Autodesk, these are the things you're going to want to look out for. So they're going to bet big on AI. And to do that, they're going to use Forma. So they're on a mission to reimagine the way the customers capture, utilize, and exchange data. They intend to empower our industry, and this is classic Autodesk language, and how the professionals use data to capture, inform decisions, and deliver projects. So it's going to be all about the data. And what's interesting about Forma is they're going to change how data is stored, how it's going to be exchanged between companies, and then they're going to build applications on top of Forma. So this is going to create a data infrastructure on which Autodesk future AEC products will be built. And what's alarming about this is that Autodesk have got access to huge amounts of project data. What's not clear is how they're going to handle that data, how they're going to sanitize the data, whether they're going to ask people's permission to use the data, et cetera, et cetera. There's a lot of unknown questions about what data they're going to use and how they're going to use it. But it is interesting that Autodesk are all in on AI. So this is where we are in a 20-year leap. We've gone from modeling to data products by the same company. So going back to my rapid career path, in 2007, we restructured the company and it became IntelliBuild, which is when I first came across it, I believe, when I was talking at a conference. 2008, I met my wife, and at that time we started working on the biggest BIM project I did then, and probably still to my career this day, which is the Cathay Cargo Terminal. So I want to talk to you about what's changed in the way we design and do coordination between 2007, 2008, and current day practice. So back then, the intention of the model for CAT Pacific was that we would do BIM correctly, and we would produce a coordinated so-called clash-free design. So again, I dug this out of an old presentation, and I thought this is quite funny. To me, this is the first digital twin I came across. So I hope this works across Zoom. Let's see. Yeah, there we go. It is working. So what this is doing, it's simulating the actual processing of cargo through the air terminal. It's based on the actual flight logs for the projected traffic of the airplanes. It's based on the capacity of the actual cargo facility, and it was used to validate the design, and then it was used to build operational models. So again, anybody who thinks digital twins are a new phenomenon, that we were at this in 2007. And just digging into the models, just to set the scene, Revit structure was used. So this was an early version of Revit. I think it was the 2008 version. And then back then, we could put in basic data into the models. So we were able to identify particular types of structure with an architectural model. And then we had all the building services models. These are all the design models. So these models are produced by the design consultants. And this is the first thing we learned was designers shouldn't really be doing MEP coordination because the contractors are the one that actually know how to do that. But we had to come up with the design of the system. So we got all the different systems. And back then, this was pre-Uniclass. So people who now use classification systems, we had to come up with our own classification system. So we had a coding system, which was mainly used to drive coordination and clash analysis. We used the models to produce drawings. So this is a snapshot of the fire sprinkler system. You can see it's quite a heavily serviced building. And then we use Revit to actually generate drawings from that. So we use color-coded drawings coming out of the models. So again, if you're not already using Revit to generate drawings, there's a big question mark as to why. And then what I thought was interesting was these slides came out of this old presentation, and it was actually a very early version of what is now ISO 19650 processes. So this was the original BS 1192 process where you have drawing production system and a publication system. So we had a very particular folder structure, which I still use on my projects in an iterative version of it, but it's still the same logic. So you have a live information folder, you have published information, you have all the different formats of the data in one location, so it's not broken down. And then you basically have all the drawings in a shared environment. So you have each of your different contract drawings and contract drawing sets. So as I mentioned, this was based on PS 1192, which obviously became past 1192. And then since then, we've obviously developed ISO 19650. And what's stunning is even though 19650 has been around at least 5 years, I can count on one hand the number of projects that are actually using it correctly. So it's at least in my area. So these standards, while they've been around for a long, long time, our industry is struggling to actually apply them consistently and coherently. And the one thing that came out of CAT Pacific, which is still relevant today, is this idea of a clash analysis matrix, which is basically solving for complexity. And the difference now is the technology that's available. So back then, all of these things were run in a manual form using Navisworks. And then every time you run these clashes, it would generate a bunch of images identifying each individual problem. And then you'd have to go through them one by one to actually solve them. There was no system for assigning issues. There was no way of managing the issues. It was a very labor-intensive, manpower-eating process. So again, that project in 2008, while it was extremely complicated back then, it did lend itself to developing a number of practices, at least in my business. And when you compare what's going on now, the tool of choice is Revisto. And Revisto has been sponsoring a number of events in Ireland. I know the guys quite well, Reese and the guys. So if you're looking for a really powerful coordination tool, Revisto is that tool. And I'm sure, while I don't know exactly what they're up to, it'll only be a matter of time before they start using AI to improve that coordination process. But right now, Revisto is the way to do coordination and modeling. So again, there's been a major evolution from the manual process that we had in 2008 to the process that we do now in 2023. So jumping forward, I just want to show you a different way of looking at this. Once we got to the construction project, the learning was massive because the amount of work during the design stage wasn't sufficient for construction. So we basically had to remodel the whole thing for construction. And one of the challenges that we had during the construction phase was identifying discrepancies between what was in the model and what was happening on site. And this is where technology has changed. This is where AI is having a massive impact. So this idea of being able to link the model to the job site, rather than using cameras, the smartphones, and just taking photographs, which is what we were doing in 2009, we would walk around, take a bunch of photographs, then go back and check the model and see what was going on. I'm going to show you how that's changed with augmented reality and AI. So these are basically some basic snapshots of what was in the model against what was installed on site. And you can see they're pretty much the same. There's always going to be variation, but it was a very manual process. So you would send out a guy on site, it would take a couple of hours, and then you would get a lot of information back. And then you had to go through the model. It was labor intensive. So if you take what we did in 2009 and you jump forward 10 years to 2019, and get kind of jump over and back here a little bit, what has become immensely powerful is augmented reality. And if you've not seen this in the real world, I highly suggest you go and look this up and get it to try it on your projects. You do need to have a BIM model to start with, but essentially what you're doing is you're using an iPad device. I prefer the iPad as against the helmets because when you start putting this technology on people's heads, first of all, it's quite heavy to carry around on your head all day. And second of all, it's not quite as practical, in my opinion. And I'll always argue the toss with the XYZ boys, but that's where we sit at the moment. So using the iPad is a way to do it. And then what you can do is you can basically overlay the model into the actual site environment. So you can actually start to check, have I got the openings in the right place for the future installation of pipework? So in this case, there's one missing, so we can identify quickly what has to get fixed. You can actually take it out and use it for rebar. So we have the guys going through the rebar inspection and making sure that all the openings in the right place, all the castings in the right place, as part of the rebar inspection process. So before we cast any concrete, we're doing our QA and QC to make sure things are done correctly. So augmented reality is a technology that is getting more and more powerful, and AI is having a major impact on. And then you can use this to mark things up. So that was a quick leap from 2009 forward. In 2012, I got married to my Malaysian wife. We started working in midfield concourse, and this is where the technology has changed dramatically in certainly the last 8 years. So where AI is going to have a massive impact is in the world of reality capture. So the world of laser scanning, drones, and reality capture is where AI is having an immediate and massive impact. And the reason I say that is, again, experience. So on this project in Hong Kong, we had to build this very complicated roof structure at the Hong Kong airport. And this was the design model. This is the fabrication model. So again, I think I presented this at a CitA event in the past, but this is a very, very complicated structural steel model with exposed steelwork. So it's actually architecturally exposed on the bottom chord of the truss. There's a lot of access ways into the ceiling space. There's a very complicated paneling system, and it's a typhoon-loaded airport because it's in Hong Kong. And then beneath the roof is a very complicated air conditioning, fire sprinkler, and communication system. And then all that is wrapped up inside this doubly curved ceiling system. So we had to make sure that the steelwork was in the right place before we started installing all the mechanical electrical systems. And here you can see these exposed cords. So in order for us to verify the installation of the steelwork during construction, we started using laser scanning. So we started scanning all the steelwork as it was erected and put in place. And then we used those point cloud scans to verify that against the models. Now, this again was a time-consuming process. We had to learn how to do the surveying. We had to learn how to get the right coordinate system set up. We had to make sure we had the right data points. And then we had to figure out how to compare them to the models. AI has now transformed all that to make it really slick and very quick. And I would go so far as to say that you don't even need laser scanning anymore. You can do this with photographs. So with a proper 360 camera and a proper bit of logic, you can actually do the same process now, quicker, faster, and cheaper. And we started off with a complicated steelwork, but what was interesting was we very quickly started realizing it had many, many more use cases. So we even got down to simpler steelwork. This is the link bridges. And we just started looking at cleats and plates and looking for outer tolerance. So you can start making use of these tools for many, many things once you start getting up and running. So that was 2012, 2014. And my son was born in 2014. You'll see another picture of him in a minute. In 2016, we moved our family here to Malaysia, and I joined the Gamuda guys to work at MRT. And this is when we started using drones for photogrammetry. So I'm going to combine the use of laser scanning, the use of drones, the use of 360 cameras in 1 second under the umbrella of AI. But this is just a quick demonstration of how we use the drones in one example. So we use the drones to create 3D models. These are basically called photogrammetry models. And this is basically a 3D model generated from a series of images taken by the drone. And what we're doing is we're comparing the construction progress, the reality of the construction progress against the intended foundation of the railway station. This is an underground railway station. So this is an open cut excavation. It's stood in rock, so it's a very stable excavation. And it's a great example of showing how drone technology can be used to monitor progress. And this, again, is where AI is having a major impact. So that basically ties me into where we are today. And what's interesting is when you look at 2023, my son recently turned 9, and in his lifespan, we've gone from doing manual class checks to exposing ourselves to some brilliant AI technology. And I just want to draw your attention to a couple of tools that I find really, really powerful and are going to make a big impact. So QPix, Reconstruct, OpenSpace, and Nazca are all AI fundamentally powered tools in the reality capture space. They use 360 imagery, they use models, they use laser scanning, they use drone imagery, and they can start doing a variety of different things in the space. So they can identify, if you look at the Nazca presentation that was done at AU last year, they can identify in basically the computer algorithm objects that are missing from a building project, objects that are out of tolerance in a building project. If you look at OpenSpace, they can tell you where you are against your actual schedule. Reconstruct have got an integration with Primavera, so you can see where you are against your actual plan. And QPix have got some very clever technology around analyzing the building. And the last one on the list here that I want to draw people's attention to is Alice. Alice is a AI-driven construction planning tool, and it's a very powerful tool. It's been used in HS2. So these are really exciting tools to look at. And they're going to make a big difference in our space, but they're all in the kind of reality capture side. There's not much AI in the design coordination space that I've come across yet, apart from Forma, which Autodesk are basically unveiling at the moment. So to wrap up my presentation and trying to keep on schedule, in order for you to be ready for the challenges, I think, as I've already said, I think AI will propel some firms forward. Those that have been successful in BIM will be immensely successful in AI. Those who are struggling in BIM are going to struggle in AI. So I think you got to figure out what you're actually doing. I've got a 3D approach to these projects, which I'm going to share with you. I think what you need to do is you need to define your problem or your issue. So just don't go out and get an AI solution thinking that you're going to be able to apply it. You need to define your problem first. Then develop a plan of attack, identify the KPIs you're going to measure, work out what potential solutions are in the market. So which of these tools are going to be useful, which are not going to be useful, and then go out and deploy them on a project, train the staff, provide the technical support, and do an evaluation. So these are my 3Ds: define, develop, and deploy. And then you will be able to determine how you're going to use these tools. Simply by picking the shiniest new AI tool is not the way to go forward. And I hope in that whirlwind tour of 20 years, you've got a few nuggets out of that presentation. And that's it. That's it for today, Alan.